All right, today we're jumping into a story about a scientific breakthrough that didn't just win a Nobel Prize, it really did change the course of modern history. And, that is not an exaggeration at all. We're talking about the key discovery that really provided the tool to pull the entire world out of the COVID-19 crisis. It's an incredible story about a technology that was just waiting for its moment to shine.
So let's really get into this, because this isn't just some abstract idea from a lab, right? This is something we all lived through. I mean, the question on everyone's mind back in 2020 was, how in the world did we get effective vaccines so incredibly fast? I mean, just try to remember how urgent everything felt back then. A traditional vaccine can take a decade, sometimes even longer, to develop. The world absolutely did not have that kind of time. The situation screamed for a totally new approach, something that could be designed and scaled up at, warp speed.
And that new approach? It was all about something called messenger RNA, or mRNA. But here's the thing. For decades, using mRNA as a medicine was kind of like a sci-fi dream. It just wasn't a reality. There was this one huge fundamental problem that stopped the whole thing in its tracks. Let's explore what that challenge was. Yeah, this is the big one. On paper, mRNA seems perfect, It's literally a biological messenger. It carries instructions to your cells telling them what proteins to build. So why couldn't scientists just inject the instructions for a piece of a virus and let our bodies learn how to fight it? What was the hiccup? Okay, so this right here shows you the problem perfectly. Look on the left. When you inject that raw, unmodified mRNA, your body's immune system just freaks out. It screams intruder and launches this massive inflammatory attack, basically destroying the message before it can even be read. But then, look over on the right. One little modification changes everything. And that is the genius solution. It's a technique called nucleoside base modification. Now, that sounds complicated, but the bottom line is this. Scientists figured out how to make these tiny, tiny chemical tweaks to the building blocks of mRNA. It's a super subtle change, but it effectively makes the mRNA invisible to those first responder parts of our immune system that trigger that whole inflammatory mess. Honestly, this is the perfect way to think about it. The modification is like a disguise. It's like putting a fake mustache and glasses on the mRNA message. It allows it to just slip quietly past the body's security guards, get inside the cell, and deliver its critical instructions without causing a scene. No alarms, no fuss, just a clean delivery of information. So, who were the brilliant minds who figured out this molecular disguise? Well, let me tell you, this was no lucky accident. It was the result of years and years of persistent and often underappreciated research by two pioneering scientists. And look, you don't have to take my word for how vital this work was. The Nobel Prize Committee themselves said it all. Their 2023 prize in physiology or medicine was awarded specifically for these discoveries, the ones that enabled the development of the vaccines we all relied on. Enabled. That's a really powerful word. And the recipients of that prize were Katalin Karikó and Drew Weissman. For years, their research into this exact problem was met with a lot of skepticism, but they kept at it. And thank goodness they did, because their dedication is the reason this powerful technology was ready to be deployed right when the world needed it most. Okay, so let's zoom out and really look at the incredible legacy here. We're talking about the journey of a single, elegant scientific idea and how it blossomed into a tool with a truly massive global impact. This lays out the whole story perfectly. It all started with that foundational discovery, right? Perfecting the nucleoside base modification. That discovery then unlocked the application, making effective vaccines possible. The impact was historic, protecting millions of people and literally changing the trajectory of the pandemic. And all of that led, deservedly, to the ultimate recognition in science. And if there's one thing you take away from all this, it should be this. The rapid vaccine rollout seemed like an overnight success, like it came out of nowhere. But it was anything but. It was built on the shoulders of decades of slow, quiet, foundational science. It's just a powerful lesson in the value of persistent, curiosity-driven research. Which leaves us with a pretty provocative thought. We've seen this technology used masterfully to fight a virus. But now that we know how to write and deliver these custom biological messages, what comes next? What other instructions could we give ourselves? I mean, could we teach them to fight cancer, repair damaged tissue, or maybe even correct genetic disorders? The story of mRNA, believe me, is far from over.